In this video, we will talk about another aspect of the method of separation of variables, the limitation. In other words, we will try to address the following question. When does it not work? I know people usually do not like negative answers. Nevertheless, in mathematics, it's important to know when or even why a method stops working. This is also an important part in the chaining of critical thinking. So let's get started. First of all, let's recall that the method of separation of variables is usually taught as the first approach in solving partial differential equation because of its simplicity. By assuming the solution is of a product form, in some cases, we can reduce the partial differential equation into several ordinary differential equations, which are easier to be solved. On the other hand, this method is so popular because it does apply to a collection of classical partial differential equations, which we'll be talking about a little bit more moving forward. Still, it is not an almighty method. We're going to look at a few circumstances in which it does fail. We will begin with the case in which some solution is not of the product type. This is our first example. Some audience may recognize this differential equation because in one of the previous videos, we did use the methods of separation of variables to find some solution to this equation, which is of a product type. Let's consider the following function u of x comma y equal to x minus 1/3 times y. We claim that this function is indeed a solution of this partial differential equation, while it's not of the product type. To verify this fact, all we need to do is just plug this function into the equation. Doing so, we just have partial u over partial x equals to 1, and partial u over partial y equal to negative 1/3. Hence, the outcome is precisely 0. And we do verify that this function is a solution of this partial differential equation. In other cases, the product type assumption just doesn't lead to a solution. Consider this example. If u is equal to the product of capital X and Y, then plane in, we should have capital X double prime times capital Y plus capital X prime times capital Y prime plus capital X times capital Y double prime equal 0. But the capital X and capital Y and their various derivatives just mix together and not separable. We simply could not reduce the problem into some simpler ordinary differential equations. So this method does not lead to any solution. To wrap up, we would love to remark that although the method of separation of variables does have some limitation, we still want to point out that the product type solutions serve as building blocks of more complicated solutions. We will look at this perspective more closely in the future. Until next time, enjoy the math.